Okay, so this problem is going to be similar to problem number 5. Again, we have x, y, and z defined with this relation, where this relation right here, and this implicitly, so what we have here is the following idea. X and y, so z, this gives z implicitly as a function of x and and y are functions of t. X and y are functions of t. That's what this is telling us here. Okay, it doesn't say it explicitly, but implicitly that's what's going on here. This implicitly gives z as a function of x and y, or this implicitly defines z as a function of x and y. X and y are independent, but they are both functions of t. Okay, so now we want to find the partial derivative of z with respect to t at the instant where all of these are true here. Okay, so the first thing that we want to do is we want to take the partial derivative of both sides. Sorry, not the partial derivative, but we want to take the derivative of both sides with respect to t. So now y is a function of t. Okay, so on the left-hand side, let's take the function, let's do the derivative of the left-hand side with respect to t. Well, by the product rule, this is going to be the partial derivative of x with respect to t times cosine y, plus, now it's going to be plus x times the derivative of cosine y with respect to t. So that's going to be times minus sine y times the partial derivative of y with respect to t. Okay, now we'll do the same thing here. So this is going to be plus the partial derivative of z with respect to t times sine y plus z. Now we'll do the derivative of sine y with respect to t. This is z cosine y times the partial derivative of y with respect to t, and that's equal to 0. There's a slight inconsistency in the way the problem is stated. So it's asking for the partial derivative of z with respect to t, but here this gives the derivative of x with respect to t and the derivative of y with respect to t. So either this should have been the derivative or these should have been partial derivatives. I'm just doing this as being partial derivatives, like that, which is why I have the partial derivatives here. Okay, and now we're just going to plug in everything. So the partial derivative of x with respect to t, we're given that's the square root of 3. Times cosine of y, well, that's pi over 3, so cosine of pi over 3 is 1/2, plus x is 3, times minus sine of y is pi over 3, so that's minus the square root of 3 over 2, times the derivative of y with respect to t, that's 1, plus the partial derivative of z with respect to t times sine y. Sine of y, again, y is pi over 3, so sine of y is the square root of 3 over 2, plus z is the square root of 3, times cosine y, cosine of pi over 3 is 1/2, and times the partial derivative of y with respect to t, which is 1, and that's equal to 0. Okay, and now we need to solve for the partial derivative of z with respect to t. But notice if we multiply both sides by by 2 over the square root of 3, this becomes 1, this becomes minus 3, that goes away and that goes away. So what you end up with is 1 minus 3, which is minus 2. Minus 2 plus 1 is minus 1. So what this becomes when you multiply by 2 over the square root of 3 is minus 1 plus the partial derivative of z with respect to t is equal to 0. In other words, the partial derivative of z with respect to t is equal to 1. If you didn't follow all of that, that's fine. All I did was I just solved this equation here for the partial derivative of z with respect to t. That's that's straightforward, though kind of tedious if you didn't realize this trick about multiplying both sides by 2 over the square root of 3. Okay,